Good day, students. In this clip, we're going to be going over 4 examples on how to solve trigonometric equations using the unit circle. So in order to get started following these examples, you need to have your unit circle. I have a virtual copy of my unit circle here that I'll be consulting during the problem solving process. All right, so let's go ahead and take a look at the first question. So the instructions are for us to solve the following using a unit circle for theta between 0 and 2 pi. Okay, since the restrictions on theta are in radian measure, that means that our solution will be in radian measures also. Okay, so let's go ahead and write down question number 1. For number 1, we are to solve -5 plus the square root of 2 divided by 5 equals -1 plus 1/5 of secant theta. Okay, so the variable we're solving for in this equation is theta. Alright, so how do we solve for theta? To do that, we notice that we have fractions in our equation. So the 5 are the common denominators of the two fractions. So let's go ahead and eliminate the 5. To accomplish this, we'll simply multiply both sides of our equation by 5. So multiply this side by 5 and multiply this entire equation by 5 to get rid of that denominator. Alright, so let's see what happens on the left side. This 5 cancels out with that 5, so we're left with -5 plus root 2 equals, if you distribute the 5 here, you have -5 plus, if you distribute this 5 to this 1/5, you have 5 over 5, which reduces to 1, and it cancels out. And then you're left with secant theta. Alright, now let's go ahead and isolate secant theta. To accomplish that, we'll add 5 to both sides. And that leaves us with, using the reflexive property of equality, secant theta equals -5 plus 5 cancels out. So you're left with root 2. Now to get theta isolated, we're going to get rid of the secant. But what we can do here is express this trig function using one of the parent trig functions. Now we recall that secant theta is equal to 1 over cosine theta. Alright, so if I apply that to the left side, if I express secant as cosine theta, then I have to reciprocate this expression right here. So if there's a 1 here, this will become 1 over root 2. Okay, so if you reciprocate secant, you end up with cosine. Now, we have 1 over root 2 here. To get rid of the radical in the denominator, you rationalize root 2. That gives us root 2 over 2. Okay, so we have cosine theta equals root 2 over 2. Now, to isolate theta, we're going to take the inverse cosine of both sides of the equation. So we have, if cosine theta is equal to root 2 over 2, we're going to do the inverse cosine of the left side, inverse cosine of cosine theta, and then we'll take the inverse cosine of the right side also, inverse cosine of root 2 over 2. So this cancels out. So we have theta equals the inverse cosine of root 2 over 2. Now, how do we solve this using our unit circle? Using our unit circle ratios, let's go ahead and consult our unit circle ratios. We have cosine is the x-coordinate. Okay, cosine theta is the x-coordinate. So in this equation right here, this is asking us what x-coordinate on the unit circle has the value of root 2 over 2. So what x-coordinate is equal to root 2 over 2? Let's write that on the side. What x-coordinate is root 2 over 2? Since we recall that cosine theta is the x-coordinate. Okay, so let's go back to our unit circle. And then take a look at all the x-coordinates that we have here. Which one has root 2 over 2? So notice we have the first one here, pi over 4 is the first one. This is negative. Let's see, this is negative. And bam, this is positive. So the only two angular values where the x-coordinate is positive root 2 over 2 are 7 pi over 4 and pi over 4. Okay? So our answer is going to be, let's go ahead and write this down. Theta has two values. Theta is equal to pi over 4 and 7 pi over 4. All right, let's take a look at question number 2. So for question 2, we have, let's write this down, 6 equals 3 plus 6 sine theta. Okay, now to solve for theta, we're going to isolate theta by getting rid of 3, 6, and then the sine function. Okay, so let's do this in a step-by-step fashion. First thing we're going to do is subtract 3 from both sides. And then using the reflexive property of equality, we can write this as 6 sine theta equals 3. Next thing we're going to do is divide both sides by 6. To get rid of the 6 here, divide by 6, divide by 6. So we have sine theta equals, reduce this, divide top and bottom by 3. You have 1 over 2. Alright, so to isolate theta, we're going to take the inverse sine of both sides of our equation. So inverse sine of sine theta, try that again, inverse sine of sine theta is equal to the inverse sine of 1/2 on the left side. The sine theta and the inverse sine cancel each other out since they're inverse functions, and we will have theta is equal to inverse sine of 1/2. Now how can we solve this using our unit circle? So this expression basically asks us the following. Now what coordinate are we looking at here? Looking at your unit circle ratios, let's look at it again. Our unit circle ratios tells us that sine is the y coordinate. Sine is the y coordinate. So which y coordinate is 1 over 2, the argument of your inverse sine function. Okay, so that's what our theta values will be. So now we're going to consult our unit circle and see which y coordinates has a value of 1 over 2, and that will be the solution to our equation. Okay, so let's take a look at that. We're looking for positive 1 over 2 in the y coordinates of a unit circle. So we have a candidate right here. Pi over 6 works perfectly for positive 1/2 in the y coordinates. And 5 pi over 6, that's good. This is negative, and Looking for the y coordinates. This is negative. So pi over 6 and 5 pi over 6 are the only ones where we have positive 1/2 on the y coordinates. So our values for theta, that are the solutions of this equation, are pi over 6 and 5 pi over 6. All right, we can put them in squiggly brackets because this is a collection of elements of a set, our solution set. Okay, so that's that. All right, let's take a look at question number 3. So for number 3, we have 1 equals -3 plus 2 cosecant theta. Okay, now to get theta isolated, we'll get rid of this -3 first, 2, and then the cosecant function. All right, so let's go ahead and get rid of the -3 first. To do that, we'll add 3 to both sides. Using the reflexive property of equality, we'll have 2 cosecant theta equals +4. Now to get rid of this 2 that's been multiplied by the cosecant function, we'll divide both sides by 2. And that yields theta equal, cosecant theta equals 2 over 1. Now since there's no 2 on our unit circle, we're going to have to use a reciprocal here. We know that cosecant theta is related to sine by reciprocation. Okay, so what I'm going to do is I'm going to reciprocate both sides of this equation as we did in number 1, and that will enable me to solve this equation. All right, so let's go ahead and reciprocate both sides. If I reciprocate this, it's going to become sine theta equals 1 over 2. Okay, now to get theta isolated, we'll take the inverse sine of both sides. So inverse sine of sine theta is equal to the inverse sine of 1 over 2. Okay, now this sine and inverse sine are inverse functions. They cancel each other out. So we have theta equals the inverse sine of 1/2. Now what does this mean in our unit circle? We know using our unit circle ratios that sine theta is the y coordinate. So this is asking us which y coordinate is equal to 1/2. So any coordinate, any point where the y coordinate is equal to 1/2, that angular value will be our solution for theta. Okay, so this is exactly similar, the same process that we did for question number 2. So let's go ahead and do it again just for extra practice. Remember what we did in number 2, we took a look at our unit circle and we found out that the y coordinate was positive at pi over 6 and it was also positive at 5 pi over 6. The other places where we have 1/2, they're both negative, so those do not fit our expectation. So the answers that we have are going to be pi over 6 and 7 pi over 6. So these are the solutions to our equation. So thanks so much for taking the time to watch this presentation. Feel free to subscribe to our channel and do post a comment to let us know what you think about this presentation. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day.